Fourth chapter, motion in a plane. In the last chapter, third chapter, we had seen a motion of a body in a straight line, means either in x-axis or in a y-axis we had seen. Now we will see that a body can be moved in the x and y plane. See, this is the board, and this board is also called as a plane. Now, when a body thrown not on the y-axis, not in the x-axis, in between x and y, this is said to be a plane. To analyze the body motion in the plane, we need to understand the vector concept and we need to know vector algebra. Because the vector concept is necessary to learn the concepts of motion in a plane. Now, we need to know what is meant by vector, what is meant by scalar, how to define them, which quantities are called as vectors, which quantities are called as scalars, and how to denote the vector and how to write the scalar and how to multiply the vectors, how to multiply the scalars, how to add the vectors, how to subtract the vectors. All we need to know in this chapter. Let's go one by one. Now, first, vector. What is meant by vector? A physical quantity like displacement, velocity, acceleration, force, torque, momentum. These are all coming under vectors. These are all possessing direction as well as a magnitude. Let's say displacement. A displacement will have magnitude and direction. Magnitude and direction. A physical quantity which has both magnitude and direction is said to be vector. Suppose if A is a vector, we will denote it as vector with a bar like arrow mark. This is a simple notation of a vector A. Otherwise, we will write in a bold, in a thick letters. This is also said to be vector. Sometimes it is typical to write all, make it very strong. The simple notation with arrow mark is a notation of vector. And coming to scalar, scalar means which is having only magnitude but not direction. So it doesn't possess any direction. What are the examples for the scalar? Mass. We will measure the mass with like 1 kg, 2 kg, but we should not denote with 2 kg in this direction, 1 kg in this direction. It cannot be. Mass, volume, time. These are the examples of scalars. And displacement, velocity, acceleration, all these terms are familiar in the last chapter. Acceleration, force, momentum, torque, such are treated to be vectors. We will possess it. We will donate as magnitude as well as direction. Now we shall see position and displacement vectors. How to find out a displacement vector using position vectors. A distance is different from displacement. A distance is a scalar. We will not notate any direction for the distance, whereas when you consider a displacement, we should notate with the direction. Let's see a coordinate axis. It's origin O. Let's say a point P, and this is a position P. Now, in order to notate the position P, let us draw a line, and OP is a position vector. OP is a position vector. Now, the body is being travelled from point P to P dash. So, again I am notating with an arrow mark. Earlier starts from P to P dash. Now, OP vector, OP again, PP dash vector, two vectors are there. Now, this is, if you calculate the distance from here to here, and this is here to here. Now, I will write the displacement vector of this is called OP dash. OP dash. This red mark indicates a displacement which will be having direction, and displacement might be lesser than the distance or equal to distance. Sometimes distance is more than the displacement. If you travel from here to somewhere and coming back here, again the net displacement or displacement is 0, whereas distance can be covered from here to there and there to here. Distance can be counted, but initial position and final position is completely related to a displacement. If the initial position and final positions are same, then displacement is 0. Now, this is called as a displacement vector. Now, we will write slowly how to write the vector concept, and vector addition, vector subtraction. Next, we should see addition of vectors. What are the methods to add the vectors by using a graphical representation? The first one, when two vectors are added, ultimately third is a result of that. First one is a triangle of vectors. Triangle of vectors. This is then extension to that. If triangle is there, you can make it many vectors are there. If you want to join it, then you also make it a polygon law of vectors. And other simplest one is parallelogram law of vectors. Slowly we will learn one by one how to add the vectors and how to find out resultant direction and how it is making an angle with the x axis or y axis. In terms of answers, we should learn slowly. Now, equal vectors. What is meant by equal vectors? If two vectors are having same magnitude and both are in the same direction, they are said to be equal vectors. In terms of magnitude, in terms of direction, both are having same. Let's say a vector A is there and a vector B is there. Both are having same magnitude and same direction. They are said to be equal vectors. So, vector A is equals to vector B. And what is the mean? How to notate a magnitude? So, mod of A, which is called as a magnitude of vector. Magnitude of vector A. Magnitude of vector A. Here we will write it as mod A is equals to mod B. Means magnitude of A is equal to magnitude of B and direction of A is equal to direction of B. Similarly, we can understand a vector A is there, let's say a displacement of 3 meters in the east direction, let's say, and a displacement of 3 meters in the west direction. What is happening here? Mod A is equal to mod B, but vector A is equal to minus vector B. So here these are called as opposite vectors. A and B are called as opposite vectors. Okay. So here the magnitudes are same but direction is different. Now another example, a vector A is there and vector B is there. I cannot call it as equal vectors, I cannot call it as opposite vectors because their directions are completely different. Here the equal vectors are making angle between them is theta is equal to 0 degrees. Here the angle between the two vectors to be theta is equal to 180 degrees. Here somewhat angle is there. Now that would be referred later. Multiplication of vectors by real numbers. When you multiply with a number like 2, 3, 4 or minus 1, minus 5 to the vector, what happens? The magnitude changes. If the positive number is multiplied, suppose let's say lambda is a number which is multiplied to a vector A, the magnitude is increased by lambda times, but the direction doesn't change. When lambda is a negative number like minus 3 or like that, the magnitude is multiplied by 3 but direction is opposite. Let's say vector A is there. Now you are multiplying lambda into vector A mod, you can extract lambda outside and vector A, here lambda is greater than 0. So the magnitude is multiplied by lambda if it is positive number. Suppose if lambda is negative, let's say, what happens? Lambda is negative, means lambda into vector A which is equals to, now you will get the negative means, suppose let's say 3 into vector A, you will get minus 3A, where we assume that lambda is equal to minus 3. Now what happens? Direction is opposite to the earlier. So the multiplication factor, whether it is positive or negative, that decides the direction of the result. Earlier this was stated to be positive, now this becomes a negative. Now we shall see using graphical method how to add the vectors. Let's see a simple way for two vectors by using head-tail method. One arrow mark is stated to be head and end of the other one is called tail. When you join head-tail in sequential manner, how to calculate the resultant vector of the two vectors. Let's see the simple addition. Thereby we go with many vectors to be, thereby we go with the parallelogram law of vectors. Vector addition and graphical method, how to add the vectors. Let's say a vector A is there, other one vector B is there. Vector A is there, vector B is there. Now how to add the vectors? This is in this way, that is in the direction. So simple to understand. If I adjust this vector A to the left, no problem, because this is simply to be this x direction. Again, if you place it here also, that is x direction. It cannot be altered anything if you shift the vector A. So I would write it as vector A here, and this is again I am not altering any direction. If you alter the direction, that becomes mistake. Now vector A and vector B. See, this is the tail of A, head of A, and this is head of B and tail of B, and head tail is there. You are going forward order. A to B, you are going forward order. Now, the resultant of this gap is there, that can be the result, but we should write it as 1 forward, forward. This is called reverse. This is called C vector. This is resultant of this one. C vector is equal to vector A plus vector B. According to a triangle of vectors, if the A and B are the vectors are taken in the same order, resultant would be taken in the reverse order. This law is called as a triangle of vectors, because we are making triangle, right? A triangle, a law of vectors. Okay. The vector addition is commutative. What is meant by commutative law? So, vector A plus vector B is equals to vector B plus vector A plus B is equals to B plus A. This law is commutative. Vector addition obeys commutative law. Addition is commutative, not multiplication. That multiplication we shall see in later case. Commutative. Now, here we are trying to see the three vectors: vector A, vector B, vector C. So, three vectors are there. Now, we are trying to see associative law of vector addition is obeying or not. Let us see that the two vectors separately, then we go with the third one. See that vector A and vector B is there. This is making one triangle. This is making one simple triangle. Now, what is the direction? This is A and B are forward direction. This is opposite direction. So, this is called as A plus B. A plus B. And other one, this is a plus B vector, and this is C vector. A plus B vector and C vector. What is this? This is another triangle which is making here. Now, this is A plus B and C. What is happening? A plus B plus C vector. This is called as a perfect resultant of this one. Otherwise, simply you can write it as vector A is there, vector B is there, vector C is there. Now, A, B or C are in the forward direction. Now, resultant can be this one, A plus B plus C. This is called as resultant one. Of course, there are three vectors are there. We use it as polygon law vectors. If all the vectors are taken in the same direction, resultant would be taken in the reverse direction. Now, I will make it in another way. Vector A is there, vector B is there, vector C is there. What is this? If B and C are the vectors, now forward order, what is this? This is taken in reverse order, which is called as B plus C vector. Now, if you are making this one, A and B plus C are in the forward order. Now, this is said to be in a reverse order, A plus B plus C. Now, A plus B plus C, I am making in bracket because this is one set of vector, and this is called as associative law. What is this? We have taken it as A plus B plus C. What is this? A plus B plus C. From this we will write it as A plus B plus C is equal to A plus B plus C. This is called associative law of addition of vector. Associative law of addition of vectors, which obeys. Students, you practice some vector addition of adding of two vectors. I'll give 4 to 5 simple problems and you pause the video and you try to solve them. Then you will come to understand how to add the vectors and how to write a proper direction. Remember, when two vectors are in the forward direction, resultant should be taken in the reverse of that. Now, let's simple one. First vector A and vector B. Find out A plus B. Second one, vector A and vector B. Find out vector A plus B. Third one, vector A and second one vector B. Find out vector A plus B. Now we go with the third one, vector A, vector B and vector C. Find out vector A plus B plus C. The bar is necessary to write the vector representation. Another one, a body like moves in the north direction like vector A, then towards east direction vector B, then southeast direction vector C, then southwest direction vector D. Now find out vector A plus vector B plus vector C plus vector D using graphical method. Simply you fill the gap wherever there, either you fill the gap like making triangle or making polygon, whatever it is. As of now we had seen addition of vectors. Now let's see how to subtract the vectors, and subtraction of the vectors will give us again vector only. Addition of vectors will give again vector only. So let's say that vector A is there and vector B is there. Resultant, let's say that the difference of the vectors will be giving like A minus B. Otherwise, you can write it as a vector R is equal to vector A plus minus B vector. You can write like that. See, this is the vector A. Arrow mark is necessary. This is called vector B. How to write the minus B vector or reverse of this one? This is exactly the magnitude wherever it is there. This is called as minus B vector. If you write it as the resultant, this one forward order R1 and this is R2. You know very well that R1 vector is equal to A plus B. R2 is equals to A minus B. So in that way, simply R1 and R2 vectors, first one is addition, second one is a subtraction of the vectors. Now, suppose if vector A is there and you are subtracting minus a vector, what is that? It becomes 0. If vector A is subtracted by again vector A, what is that? That is 0. 0 vector, which is called as a null vector, which is having 0 magnitude. 0 magnitude and unspecified direction. Simply you are starting from origin, a person like starts from origin O and travelled in the east direction about 500 meters, and the moment it turned back from there, he was ended, he started from there, again coming back and reached the same destination. Now again 500 meters travelled reverse. The distance, first one 500 meters and another distance reverse direction 500 meters, total distance is 1000 meters, but the displacement is 0. Displacement is 0 because displacement always refers to initial and final positions. Here initial and final positions are same, so that the vector A minus vector A means is equal to 0 vector. The simple example. Addition of 0 to the vector A, to the vector, not A, but every time generally we call it as vector. Vector A plus 0, again what happens? It's A only. Or 0 plus A vector is again vector A only. And multiply with 0. Now what happens? 0 into A vector, simply 0. Okay, 0 into A vector becomes 0. So when it is added, of course, when it is subtracted, no issue, A minus 0 is equal to vector A. But when it is multiplied, the entire result becomes 0. This sometimes it refers, it will be useful in the problems. Now another method we would see a parallelogram of vectors of addition. Earlier we had seen triangle law and polygon law. Now parallelogram, you know very well, parallelogram, there are 4 sides. If the 2 vectors are there, now if you want resultant find out resultant of 2 vectors, generally we use a parallelogram law of vectors, which is very easy, which is important also. Let's say this is a point and vector A is there. Of course, this is a vector B is there. See, remember, the starting point of vector A is same, starting point of vector B is also same. Now, how to write a resultant of these two? Simply, I am taking an extension of this one parallel to B. This is now parallel to A. Simply, it is said to be a construction of a parallelogram. Now, how to write a resultant vector? Resultant vector can be, this is vector A from starting point O and vector B is starting point B. The resultant should also be drawn from the O where the 2 vectors were started, R. Now vector R is a resultant vector which is equals to vector A plus vector B. So if the 2 vectors are started from a point O, the resultant can also be drawn from the point O. That means where the 2 vectors were started, the resultant can also be drawn from the points where they have started. So R is equals to vector R is equal to vector A plus vector B. This is a simple parallelogram law of vectors. Parallelogram law of vectors. Anyhow, we should see the proof of it, why this is taken directly and how to calculate the magnitude of R. Simply you write it as vector A plus B. Magnitude of this one, a mod of A plus B, nothing but magnitude. And you also remember the angle which is taken to be theta, where r vector is making an angle theta with b. We will understand by solving one simple problem, then we'll come to understanding with the other problems also. A problem now in application of parallelogram law. Rain is falling vertically with a speed of 35 meters per second. Wind starts blowing after some time with a speed of 12 meters per second in east to west direction. In which direction should a boy, a person like, waiting at bus stop and hold his umbrella? So don't think that the bus stop is covering his rain. There is a roofless bus stop. Anyhow, the boy is wetting under the rain. Now he has to protect himself. In his hand there is an umbrella, and in order to protect himself from the rain, he has to hold the umbrella. And the question is, in which direction the umbrella has to be held? Let's see simple. Let's picturize the problem. Then we'll come to numerical analysis. Of course, this is north, south, east, west. This is northeast, southeast, southwest, northwest. 45, 45, 45, 45, total it will be 360 degrees. Here, rain is obviously falling down. Rain is falling down, downward direction, vertically downward. Now, how the wind is blowing? The wind starts blowing east to west. So this is called as a wind direction. Now, a person like a boy is simply waiting for bus. So meanwhile the rain is coming. So umbrella is there, umbrella has to be held, right? Now velocity is a vector with a direction. Speed is only magnitude without direction, right? Now the rain is falling down, Vr is equals to 35 meters per second. Another one, east to west direction, wind is there, wind speed Vw is equal to 12 meters per second. Now apply parallelogram law of vectors. Two vectors are started, means they have started from same point like origin. Now I would draw a resultant of this one is equals to, this is a direction which is called as Vr vector plus Vw vector. Vr vector, Vw vectors. How to find out the resultant of this one? You know very well Pythagoras principle. This of course you write it as r vector. Now if it is making an angle theta, the construct right angle triangle Vr, and this is called resultant vector r vector making an angle theta with vertical, which is like a rain, and this is called as Vw. The magnitude is 12 meters per second. This is 35. Now the magnitude of r is equals to under root of Vr square plus Vw square. That means 35 square plus 12 square. You calculate it. This is 37 meters per second. That is called resultant velocity, right? Now again extending to that, this is 35 meters per second and this is 12 meters per second. This is an angle. I want to find out angle. This is called opposite side, this is adjacent side. So definitely we go for tan theta is equal to 12 by 35. Theta is equals to tan inverse of 12 by 35, which is equals to theta is equals to tan inverse of 0.343. If you go with the calculator, this is 19 degrees, right, which is about 19 degrees. Now the answer comes as actually 19 degrees with resultant velocity made with vertical, that is rain falling down. So this is what actually direction of the rain where the person feels because of wind is there. This is VR1. Now a person is here. Now he has to hold the umbrella against to do this. He has to hold the umbrella against to this. So earlier the umbrella was here. Now person is holding like this. Now what is happening? Towards east direction with the vertical, the umbrella has to be held in order to protect from the rain. So in another problem we have to solve the same concept, but the direction has been changed. Earlier east to west was there, now west to east. A simple numericals were changed. Now the same, you have to find out in which direction the boy should hold his umbrella in order to protect the rain. So you have to solve it. This is a simple concept of vector addition, a triangle of vectors and parallelogram of vectors, and you try with the examples, learn the concepts slowly, and we shall see in the next class about the proof of parallelogram law of vectors and components of vectors, how to categorize the component of a vector like x component, y component. Okay friends, see you tomorrow in the tomorrow's class.